Hello everyone, so today I'll be covering question number 32 of GATE 2011. For the cantilever bracket PQRS loaded as shown in the adjoining figure, PQ equal to RS equal to L and QR equal to 2L. Which of the following statement is false? Option A is the portion RS has a constant twisting moment with a value of 2WL. Option B is the portion QR has a varying twisting moment with a maximum value of WL. Option C is the portion PQ has a varying bending moment with a maximum value of WL, and the portion PQ has no twisting moment. This is option D. It's a 2-mark question. For this type of problem, you can refer to lecture series on engineering mechanics by Professor K. Ramesh, Department of Applied Mechanics, IIT Madras. Now let's see how to solve this problem. Let us first draw the free body diagram for this bracket PQRS. So let's say this is section PQ. Since there is a point load W at P, so there will be equal and opposite force at Q also, so it will be W here in upward direction. Moreover, due to this point load W, we will have a bending moment at Q, and the value of this bending moment is force into length, and force is W and length is L, so it will be WL. So this is the free body diagram for the portion PQ. Let me use different color for the moment. So this is the moment WL. Now let's see member QR. Since this is W load upwards, so this point will have an equal and opposite point load W in downward direction. Now let's see how this moment will be transferred. Since it is in clockwise direction, this WL is in clockwise direction, so at this location this WL will be anti-clockwise direction, plus this WL is bending moment for the member PQ, but it will become a twisting moment for member QR. So it will be a twisting moment in anti-clockwise direction. So according to the right hand thumb rule, the direction of the twisting moment will be outward to the cross section. So, and it will have a magnitude of WL. Now let's move towards point R. Since it is having W load downward, so R point will be having W load in upward direction, so it will be W here. There will be a torque or the twisting moment in outward direction opposite to what it was in at point Q, so it will have a magnitude of WL. Moreover, due to this load W, there will also be a bending moment here, which will be in this direction, so it will be, and the magnitude of the bending moment will be 2WL. Let's look at member SR now, starting with the point load. So we have a point load W here in upward direction, so at point R it will be downward direction W. There is a twisting moment WL here. This twisting moment will become bending moment for member SR. This twisting moment has a direction, is twisting this member QR in a clockwise direction. Therefore, it will become a bending moment for member SR in anti-clockwise direction, and it is having magnitude WL. There is a bending moment 2WL, which is bending moment for member QR, and it is in clockwise direction. Therefore, for member SR it will become a torque in anti-clockwise direction. Torque in anti-clockwise direction means according to the right hand thumb rule, it means in outward direction. So it will be a outward directing torque having magnitude of 2WL. Now let's move towards point S. So at point S, since this load is in downward direction, so we will have a point load in upward direction. Let's see the torque. We have a torque in outward direction here, so we will have a torque here in outward direction opposite to that at point R. So it will have a magnitude of 2WL. Moreover, there is a bending moment WL, so we will have a bending moment in this direction WL. Also, due to this load W, we will have another bending moment which will be in opposite to the previous bending moment. Hence, these two bending moments together will cancel out each other and there will be no bending moment at this point. Now we are done with the free body diagram. Let's see which of the following options is correct. The first option says the portion RS has a constant twisting moment with a value of 2WL. So let's see portion RS. So it is correct that it is having a constant twisting moment of 2WL. The second option says the portion QR has a varying twisting moment with a maximum value of WL. So the portion QR is having a constant twisting moment, not a varying twisting moment. The constant twisting moment of WL, but it says it is having a varying twisting moment. So this option is wrong. Let's see the third option as well. The portion PQ has a varying bending moment with a maximum value of WL. So it is correct that the portion PQ has a varying bending moment because it is 0 at end P and it is maximum at Q. So it is varying bending moment of with maximum value WL. So this option is also correct. Option D says the portion PQ has no twisting moment. So in our free body diagram, we can see that the portion PQ does not have a twisting moment. So this option is also right. So we were asked which of the following options is false. So our answer will be option number B, which is false in this case.